Okay. So let us do the next problem based on capacitance. Okay, so first problem we already did. It was based on the concept of two unequal spheres attaining the same potential once they are connected together. That was the first problem. Now let us do the second problem. Two identical metallic spheres, metallic plates. Here you have two identical metallic plates. In the previous question it was two unequal charged spheres. So here it is two identical metallic plates are given charges Q1 and Q2 such that Q1 is greater than Q2. Okay, it is mentioned in the question you have two charged plates. One is having charge Q1 and the second plate is having charge Q2 such that the charge Q1 is greater than Q2. That is given in the question. Okay. If they are now brought close together to form a parallel plate capacitor with capacitance C. So if you have two charged plates brought together, it forms a capacitance. Okay, so having capacitance C, what will be the potential difference between the plates? We need to find the potential difference between the plates. In terms of what? In terms of C, Q1 and Q2. In these problems, what they are expecting is the answer should be based on the terms given in the question. Here the terms given is capacitance C is given, charges Q1 and Q2 is given. So your final answer should be having Q1, Q2 and C only. Okay, so let us see how to do this problem. So it's a parallel plate capacitor. So obviously we know the capacitance of a parallel plate capacitor is A epsilon naught by D. So that is the first step. So capacitance due to a parallel plate capacitor, that is what A epsilon naught by D. Okay. So capacitance due to parallel plate capacitor is A epsilon naught by D. Now here you have a area we don't know, D and all we don't know. So we need to bring area and all in terms of charge. So what you can do, you can apply the formula of surface charge density. Okay, so that is electric field due to the first plate. I am finding electric field due to the first plate will be sigma by 2 epsilon naught, and sigma is what, Q1 by A by 2 epsilon naught, and the second plate will be sigma by 2 epsilon naught, Q2 by A 2 epsilon naught. So these are the electric field due to both the plates, E1 and E2. Now what I am going to find is net electric field. Net electric field will be E1 minus E2. Why? Because Q1 is greater than Q2 is given in the question. Q1 is greater than Q2. So here you have to take net electric field as E1 minus E2. So you got the net electric field. Now you need potential. Potential formula, which formula you have? C equal to Q is equal to CV formula is there, but there you cannot apply that over here because you have, it's like a parallel plate capacitor, two charges are there, so we cannot apply that formula here. So you can try with this potential gradient formula. So you have the net electric field. So as per potential gradient, electric field is equal to potential by distance, or you can see the potential is E into distance. Net electric field is this, you substitute that value of net electric field into distance is D. Now here you can see A epsilon naught and D is there. So C is equal to A epsilon naught by D, or 1 by C will be equal to what? D by A epsilon naught. So for D by A epsilon naught you will substitute C. So you will get the net potential as what? Q1 minus Q2 by 2C. Okay, is it clear the problem? So here we were finding the net potential due to two parallel plates charged Q1 and Q2 placed in the form of a parallel plate capacitor. So the net potential is Q1 minus Q2 by 2C. Okay, check out the problem.